the X-59, which is going to fly this year as well. A supersonic but low sonic boom flight that can fly over populated areas. So let's hand it over to the Armstrong Flight Research Center, who are joining us live.
Thank you very much, Administrator Nelson, and welcome back to Armstrong Flight Research Center. 75 years ago, the course of aviation was changed forever when the late Chuck Yeager broke the sound barrier in the first experimental aircraft, the X-1. Today, NASA continues that tradition of pushing the envelope through experimental flight in pursuit of advancing sustainable aviation for all of us. I'm standing in front of the X-57 Maxwell. It's a Tecnam P2006T that's been retrofitted as an all-electric aircraft. I have with me here one of NASA's test pilots training to fly the X-57 for the project, Mr. Tim Williams.
Hi, Matt.
Hey, Tim. So, Tim, let's just start. What is the X-57 and what makes this a unique aircraft?
Well, this is NASA's first all-electric crewed aircraft. And it's been a couple years going, but basically all electric motors, and it has a battery as well. So it's kind of cool stuff.
Excellent. Can we get a closer look?
Sure, absolutely.
I want to ask you, you've flown so many different NASA aircraft in your career here. What is it like training to fly a unique aircraft like the X-57?
The key to any successful project like this is a simulator. And it's part of the whole evolution when we go test. I fly, I go back to the simulator. We've done a lot of work over the last couple of years in building up that simulator to match it exactly what we have in this cockpit. You know, it's just me in this one. Now, I have normally 4 seats, but we took out 1 seat, put an instrumentation pallet, and the rest of the airplane is all batteries. So I can't wait to fly this, believe me.
Appreciate it, Tim.
You
Thank
bet.
you. Looking forward to it. I'm going to kick it up to my colleague Sarah Mann, who's with Heather up at the X-57 simulator. Sarah?
Thanks, Matt. We're here in the X-57 simulator with Heather Miliska and sim engineer Ryan Wallace. Heather, can you share with us the contributions the X-57 has given to industry?
Sure. The X-57 project has made significant contributions to industry. As a reference platform, we're able to influence industry, influence standards, and the future of electric aviation. The industry is interested in distributed electric propulsion, and with that, the project started with LeapTech. And LeapTech was a modified electric wing that we put on a semi-truck that we drove on the lake bed here at Armstrong Flight Research Center, and we were able to prove and validate that our motors could produce 300 horsepower.
Can you tell us about the batteries?
Sure. Our NASA engineers designed batteries that could cover the entire flight profile, and we did this safely to make sure that there was no thermal runaways, and so we were able to share this publicly.
Great. Thanks for sharing all this, Heather. Matt, back to you.
Thanks very much, Sarah. I have Sean Clark here, who's NASA's principal investigator for the X-57 project. And Sean, I know it sounds like we have an important milestone coming up for this aircraft. I want to ask you about that, but also you and I know that NASA's goal is to share the electric propulsion design and airworthiness process with regulators. But why is that important?
Yeah, thanks, Matt. We're really excited to take all of the engineering lessons learned that we're putting into this aircraft and get it into flight this summer. So we're all working toward that right now. And what's really important is that we learn from the fabrication and engineering development and airworthiness process and share that back to regulators and standards writers so that the aircraft of the future can take advantage of all the research that NASA is doing here and put them into the next generation of electric aircraft.
It sounds so awesome. Thank you, Sean.
Yeah.
So the value that the X-57 project is already producing for the sustainable aviation industry is foundational, and we're proud to be paving the way for NASA's new line of crewed experimental aircraft, also known as X-planes, to include the truss brace wing, which is coming soon, as well as the X-59, which is NASA's quiet supersonic X-plane that could open the future to quiet supersonic flight over land, cutting flight times commercially in half.